गुड मॉर्निंग। एक बार आप सभी का मैं इस इंटर्नशिप ट्रेनिंग प्रोग्राम में स्वागत करता हूं। और आज का जो इंटर्नशिप ट्रेनिंग प्रोग्राम का पार्ट है, इसमें अभी तक मैंने जो कुछ आपको बताया एक रफ मैनर में बताया था। इसका थोड़ा सा टेक्निकल पार्ट हमारे नीरज सर बताएंगे। इनका भी काफ़ी बहुत एक एक्सपीरियंस है और इन्होंने भी सन 99 से वर्किंग अलग अलग फील्डों में काम किया है, अलग अलग ऑर्गेनाइजेशन में भी काम किया है। तो उम्मीद करते हैं कि आप लोगों को भी थोड़ी सी जानकारी मिलेगी और अच्छी सी चीज़ें गेन करिए। मन में कोई भी डाउट या सवाल हो जरूर पूछिएगा और अपने साथियों को बोलिए समय से ज्वाइन करें। और ताकि समय का अभाव रहता है हम लोगों के पास में भी, तो जो टाइम आप लोग के लिए निर्धारित किया है उसमें कोशिश करें सभी के सभी लोग प्रॉपर तरीके से ज्वाइन करें। तो नीरज सर, आप तैयार हैं?
हाँ, I'm ready.
ओके, नाउ आप स्टार्ट कर सकते हैं।
Okay, good morning to all of you. Today we discuss about telecom network switches. So at present, the world has undergone many changes since the evolution of man. For instance, the exchange of information was initially in the form of sign and sound. This transition to the language and script form with advanced inventions. The communication from one place to another, which is called for distance between individuals, was carried through letters sent by pigeon and between two groups through drum beats or semaphores. Man used to travel through long distance to pass on messages. Today, world is more an age of communication. The advancement of communication technique has increased the speed with which the transfer of information takes place. This development has not been an easy process. At the onset of the invention of communication system, the invention and uses of telephony was the most important one. The way the system evolved from a basic system into an essential multi-purpose friendly gadgets today leaves one and all astonished, knowing the innovation made out of the merged resources available on those days. The exchange of information between two or many individuals is called communication. The word tele is a Greek word which means distance. Hence, telecommunication means the exchange of information between two distant places. Telecommunication represents the transfer of information from an entity at one place to an entity to another place, whereas the information can be in the form of data, voice, or symbol. The entities can be human being, computer, phones, or so on. In telephone conversation, the one who initiates the call is referred to as the calling subscriber, and the one from whom the call is destined is the called subscriber. In March 1876, Alexander Graham Bell invented and demonstrated his telephone set and the possibility of long-distance voice communication. He demonstrated the point-to-point communication in which a calling subscriber chooses the appropriate link to establish connection with the called subscriber. This system also required some mode of signaling to alert the called subscriber about the incoming call and a signal to indicate the calling subscriber when the called subscriber is busy on another call. So this is a pictorial representation of how a communication has been take place. So both at the initiator as well as destination point and instruments are there. Let me interrupt you for just for a few seconds. Hello. Sorry for interruption. So for making a communication between two endpoints, different mode of communication has been placed. Different equipments are required. So in the current scenario, various technologies has been established a communication between two endpoints. Now, the need for switching exchange. As you seen in the earlier image, that the point-to-point connection for establishing communication requires a telephone sets to be linking using wires. If the number of telephone sets or the subscriber present is low in number, then there is no problem. But if number R is high or moderate, then the connection will lead to mess. So nth point-to-point connection for n entities. Here in this figure, 5 connection we have made. So we need n-2/2 links. All these links form a network. Network with point-to-point links among all the entities are known as fully connected network. The number of links required in a fully connected networks becomes very large, even with moderate values of n. Hence, a system of switching the network is needed in between these subscribers. Alexander Graham Bell recommend the switching between the subscriber using a switch office that maintains the telephone connections. This connection network cannot be simply made with the telephone sets and bunch of wires, but a good system is required to make or break a connection. This system is known as switching system, or you can say switching office, or in general we are called exchange. With the introduction of switching system, the subscribers, instead of getting connected directly to one another, are connected to a switching office and then to the required subscriber. In this figure, we try to understand the switching system. So the need for traditional connection between the subscriber is reduced. All the subscriber need to have a connection with the switching system only, which makes or break any connection requested by the calling subscriber. The switching system is also called telephone exchange. Take care of establishing the calls. Hence, the total number of such link is equal to the number of subscriber connected to the system. Signaling is also required for the switching system to establish or release a connection. It should also enable the switching system to detect whether a call subscriber is busy, and if so, indicate the same to the called subscriber. Now, in the right-hand side, there is one telephone model. With the help of this, we try to understand what is going on in the early stages. So in this figure, you see that there is one dialer part, and the microphone are connected to a stationary wooden plank, and the speaker to listen was connected by a wire at the side. The top portion of the telephone has 2 bells connected. These bells ring when there is an incoming call. So this is one of the earliest model of the telephone, and the telephone set of the calling subscriber and the call subscriber are connected through a switching system or a telephone exchange in order to establish the call requested. Now we discuss classification of switching system. So classification of switching system are based on electronic, mechanical switching system, and another one is automatic system. In automatic, once again we divide electromechanical and electronic, in which VLSI based ICs are used. And here designated programs, or you can say softwares, are used to control hardware, and it is termed as stored program control. In electromechanical, the first or more popular exchange name is Stauser, or you can say step-by-step exchange. Another one, which is the advanced version of Stauser, is known as crossbar. Then in electronic, there are two modes are available. The first one is space division switching, and the second one is time division switching. In time division switching, a digital switching is there, and another analog switching is also there. In digital switching, space switching is there possible, and time switching is possible. This is not possible in analog, and after much research, scientists able to produce a combinational switch in which a space switch as well as time switch is available. So they are available in the form of TSSH. Here T stands for time and is S space for space. So this is a simple example of one IP based private exchange. So in telephony, a switch is nothing but called a telephone exchange that connect two or more digital voice circuit based on the dialed number or some other criteria. There are various type of switches, include PSTN, stands for public switched telephone network exchanges, and another one is termed as PBX, private branch exchanges and key system. Private branch exchanges are used in large enterprises or corporate environments to switch internal calls and enable access to the PSTN, while key systems are used for the same purpose in similar organization. Early switches were manually operated. Caller lifted the receiver and asked an operator to connect the call to a specified number. The operator would make the connection by physically plugging the line into a jack on the switchboard that correspond to the destination number. If the destination was non-local, then the operator would connect the call to a trunk connected to a remote switchboard and ask the forend operator to connect the call. So this is the scenario adopted in the early stages, and how exchanges are look like shown in the figure. Now, modern digital telecom switches uses computer processing and electronics to establish phone calls automatically across telephone circuit. And it is basically controlled by using signaling system 7 or SIP protocol in the case of w.e.f network. TDM technology stands for time division multiplexing. It allows multiple simultaneously call to be transmitted over a single circuit, dramatically increasing the capacity of the network. The component of a digital telecom switch generally includes cabinet, logic cards, control cards, power cards, backup batteries, handset, and trunks connection to remote network. The latest switch offers a wide range of features such as auto attendant, automatic call distribution, call forwarding, call park, conference calling, direct invert dialing, interactive voice response, music on hold, voicemail, and many more. Now, what is actually happens? So, question arises in our mind, what is switching? Switching is the method that is used to establish connection between nodes within a network. Once a connection has been made, information can be sent. Telephone switch usually refer to the switching of voice channels. There are a number of different ways to maintain local switches, tandem switches, and transit switches, and any number of them can play a part in creating a connections. In local switches, they provide switching for a specific area only. Subscriber loops connected to the local switch in that area. Another one is tandem switch, which is used to interconnect switches at various sites within the network. The third one is transit switch, which is very similar to a tandem switch, except it is used for long distance connection. Now we're talking about electromechanical switching system. Electromechanical switching systems are a combination of mechanical and electrical switching type. The electrical circuits and the mechanical relays are deployed in them. The electronic mechanical switches are further classified into two ways. The first one is step by step, and the second one is crossbar. In a Stauger switching system, or you can say step by step, in this switching system, its name is also called Stauger's switching system, as its inventor A.B. Stauger. The control functions in a Stauger systems are performed by circuit associated with the switching element in the system. So let's watch this video to know more about step-by-step Stauger switching system. Please confirm whether video has been shown to you or not.
No, sir.
No, okay, just a minute.
No, sir. This demonstration model describes the operation of a step.
Now please confirm whether video is available to you or not.
Yes, sir.
Yes, sir.
Anything else you have seen?
No, sir.
Okay, just a minute. I think some more issue is there.
ये दिखाई दे तो रहा वीडियो?
एक मिनट सर.
Order exchange. This demonstration model describes the operation of step-by-step exchange in connecting one caller to another. One customer picks up their telephone. The first stage encountered at step-by-step exchange is the uni-selector. Every customer line has a uni-selector with 25 outlets that connect to the first switching stage of the exchange called the group selector. The uni-selector checks each outlet, looking for a group selector that is free to use. Group selectors are common equipment because they are shared by all customers. They step in response to the pulses from a telephone dial. When the calling customer dials a digit, the dialing pulses are responded to by an impulsing relay. This causes a mechanism called a pall to raise its carriage each time it receives a pulse from the impulsing relay. When the last of this stream of pulses has stepped the carriage according to the digit dialed, the group selector stops moving vertically and drives around the outlets of the bank at that level, looking for a free switch in the next switching stage. Each group selector responds to a digit in the called party's number, except for the final two digits which control a special switch. This demonstration model has two group selectors and a final selector. This arrangement would cater for numbers from 1111 to 0000. The extra selector shown is known as a special selector. This is used for high volume calls such as information, time, etc., and larger customers. Its operation will not be covered in this demonstration. The final selector handles the last two digits. This switch doesn't automatically cut in at the vertical level when it's reached, but waits for the last digit of the called party's number to control how far around the bank it steps. The reason for this double action is that we are now leaving the common equipment type switching, where any free switch in the next stage can handle the impulses. We are seeking an individual number. The final selector steps up to the required level and waits for the last digit. When it receives the last digit, it steps around to the correct outlet. The calling party is now connected to the called party. The phone rings and the call is answered. When the customers have finished their call, they hang up and the switch is released to be ready for the next call. This concludes the demonstration of the step-by-step exchange model.
Now, any question from your side regarding Strausser switching system working? Okay, the next switch is crossbar switch. The crossbar switch system have hardwired control subsystem which use relays and latches. These subsystems have limited capability and it's virtually impossible to modify them to provide additional functionalities. Now, how crossbar function when one call has been initiated by watching this video.
You're looking at an electromechanical crossbar switch running through a scanning cycle. Electromechanical crossbar switches offer the following admirable features: fast operation, a high degree of mechanical reliability, minimal mechanical motion, high quality electrical contact conductance, a very long lifespan in terms of its number of operations capability.
Now crossbar switch is working is same as key scan function. I think you already studied one IC 8279, which is used for keyboard interest scan. Please confirm whether you have studied microcontroller programming, microprocessor programming, and various kind of ICs like 8255, 8179, 8279, 8155.
Yes, sir. We have. Yes, sir.
So you are familiar with the key scan, how key scanning has occurred. So same principle is used in crossbar switches. Now next is electronic switching system. The electronic switching systems are operated with the help of processor or a computer which control the switching timing. The instructions are programmed and stored on a processor or computer that control the operations. So this method of storing the program on a processor or a computer is called the stored program control. If you familiar while learning the microprocessor 8085 and 8086, so same concept, stored program control has been used, and different IO pins are there. And if you learn a little bit about microcontroller architecture 8051, so here 2 or more ports are there. So each port we can control independently, right? And we are scanning the keys based on time division multiplexing. But when we provide the entire bandwidth, then we can say we are switching, space division switching. Means the entire space, entire bandwidth has been available to a particular program for a particular time. So we can integrate a space division switching and time division switching simultaneously. Now more about this, we try to understand by this video.
Today's telecoms sector is at the heart of changes that will shape our world. From smart cities to connected health to autonomous cars, new hyperconnectivity will transform how people live and work, heralding a new era for operators and their customers. As new technologies converge, for telecoms companies, investment in networks is on the critical path. The challenge is how to update existing networks, speed up time to market, and evolve the self-optimizing networks of the future. This isn't just a technology revolution, it's a business transformation. Atos works with telecoms companies and partners worldwide, creating next-generation telecoms networks, virtualizing and transforming at the core and at the edge, optimizing network operations, enabling innovation, while ensuring end-to-end cybersecurity for compliance and public trust, and accelerating decarbonization to net zero. Whether you've made the move to next-generation telecoms or want to take the first step, why just dream? Let's build the future together.
So in the current scenario, how telecommunication network has been. So as you seen in the figure that subscriber lines are there. So few subscriber lines are connected to a particular switch, and each switch has been connected to each other with the help of some lines, and that lines we can say a trunk. So A telecommunication network is nothing but a group of systems that establish a distanced call, and it is a part of telecommunication network. From the early to the later stages of the 20th century, when a person needed to make a distant call, the call was first routed to the operator at the nearest switching center. So let me take here, there is a one subscriber wish to make a call to the subscriber at this end. So subscriber is connected to the switch SS3, and another distant end subscriber connected to the switch SS2. So call has been first goes either to SS1 switch or goes to the SS4. So there is a routing plan is there, and we already defined prior a particular call for SS2 routed to SS1 switch or SS4 switch. And there is a possibility, as you see, that there is a path between SS1 and SS4, and maybe the path between SS1 and this SS4 path may be break, or SS1 and SS3, this path may also break. So in that case, the path has been gone, or it follow the alternate path, and call has been routed via SS4 to SS2. So this way has been occur in the earlier stage, and same concept also implemented there, but not it has changed something. As in the earlier setting, only the main thing is that only the circuit switching is available, but now two more advanced switching is available, known as message switching and packet switching. So in each switch there is inlets and outlets, and the set of input circuits is known as inlet and outlet. So N indicate the inlet and the outlets are indicated by M. So switching network has N inlets and M outlets. And it is available in the switching matrix, as you seen in the keypad. So predefined hardwares are also available, and their connection has been made by making some softwares. Now the type of connections. So there are 4 type of connections are possible. The first one is local call connection between 2 subscribers in the system. The second one is outgoing call connection between a subscriber and an outgoing trunk. Third one is incoming call connection between an incoming trunk and a local subscriber. The fourth one is transit call connection between an incoming trunk and outgoing trunk. Now, when the number of inlets is equal to the number of outlets for a switching network, such a network is called a symmetric network, which means input and outputs are equal. And we also called a folded network. So in a folded network, the number of inlets are N, and which comes as outlet again, and we can say it is folded back, right? Now there are 2 more terms which is very important. The first one is traffic. So the calling rate and the average holding time is defined as the traffic intensity. So continuous 60-minute period during which the traffic intensity is high, we can say it is a busy hour. So when the traffic exceeds the limit to which the switching system is designed, a subscriber experiences blocking. Now to measure the traffic, we can use a term alarm, and this term is internationally accepted as a unit of traffic intensity, and one Erlang is equal to the 21 circuits continuously occupied through a given period of observation. So one Erlang is equal to 21 connection continuously occupied for a given period of observations. Now, this is a figure for switching system. So first one is switching network. So switching network, it provides a path between the called subscriber and calling subscriber. Now next is control system. So control system, here you see that these are the incoming interfaces and these are outgoing interfaces. So in between them, switching network reside. Now control system is this one, and this is the critical part of the switching system, which actively establish the switching path by identifying the inlet and outlet lines and interpreting the signaling information received on these lines. The control subsystem controls the making and breaking of the connection by sensing the signal transfer on the lines. The control subsystem send out signaling information to the subscriber and other exchanges connected to the outgoing trunks. Now, the another term which is most important, or you can say blood flowing in a system, is signaling. The signaling formats and requirement for the subscriber, the trunk and the subsystem differ significantly. So according to a switching system provided 3 different forms of signaling: subscriber loop signaling, inter-exchange signaling, and intra-exchange signaling. Now, trunk interface. So trunk interface is used for connection between the switching systems are terminated at this port. The trunk interface is the point where trunk lines are connected to the system. Now next is subscriber lines. These lines are used for connection between the subscriber and the switching network. Line scanning unit. It is used to sense the signaling information from the respective line. The information obtained from these lines are given to the control subsystem to identify the inlets and outlets. The next one is distributed units. The distributor units are used for distributing or sending out the signal information or the respective line. Junctures here. It provides a folded connection for the local subscriber and the service subscriber. Next, we discuss dialing. Unlike a manual switching system, an automatic switching system require a formal numbering plan or addressing scheme to identify the subscriber. Numbering plan is where a number identifies a subscriber is more widely used than the addressing scheme in which a subscriber is identified by the alphanumeric string. So there are a need to be a mechanism to transmit the identity of the called subscriber to the exchange. The mechanism should be present in the telephone set in order to connect the call automatically to the required subscriber. The method prevalent for this purpose are pulse dialing and multi-frequency dialing. So, as the name implies, the digits that are used to identify the subscribers are present by a train of pulses. The number of pulses in a train is equal to the digit value it represents, except in the case of 0. So from 0 to 9, each number there is a train of pulse except 0, which is represented by 10 pulses. Successive digits in a number are represented by a pulse train. So these pulses have equal number of time interval, and the number of pulses produced will be according to the number dialed. Two successive trains are distinguished from one another by a pause in between them known as interdigit gap. So there is a one digit and another is the second one digit, and interdigit gap is there. So system able to differentiate between these two digits. So there is a time cycle is there, and 33% time of the total has been the level of pulse is high, and 67% part has been off, right? And 10% of the tolerance has been acceptable. Another one is multi-frequency dialing, or you can say dual tone multiple frequency, in which each digit has been identified by two frequencies. As you seen in the figure, suppose I want to identify one. So for identification of one, I am checking whether pulse whose frequency is 1209 and another frequency 697 is present. If a signal possesses 1209 Hertz and 697 Hertz frequency, then I treat it as that one has been present. Similarly, for 0, if the incoming signal possesses two frequencies having 1336 Hertz and 941, then I assume that the number is 0 has been transmitted. Now, this is a table in which you see for a particular one. Suppose I am pressing a button 1. So there is a DTMF IC is there, which generate two frequency. One is from lower band and another one is higher band. So the frequency is 697 and 1209. And And the IC has generated a binary coded BCD coded output, and which is shown 0001. So suppose I want a 0. So 9 up to 9, it is similar, but 10 has been, instead of A, it is represented as 0, and it generates the two frequencies. The first one is 941 and another one is 1336. Now question arises, how I can identify these frequencies. So 4 low band filters are available and 4 high band filters are available. So they are basically band selectors, filters are available within an IC. So if any particular designated frequency has come, so that may pass out of these 8 any outputs, and we able to get that a particular frequency is there, and according to that 0 or 1 level has been initiated. Now signal tones. Signaling tones are basically, it is earlier manual exchanges are there, so we can replace. So the need of operator has been removed, and basically earlier what actually operator did, so that may be replaced, and there is a flow that happens. So when calling subscriber calling, so it is ready to receive the identification of the called party. It informed the calling subscriber that the call has been established. So how we can know? So there is always a signaling is there. So a different kind of signal has been used for particular thing, and ring the bell of the call party, then inform the call subscriber if the call party is busy. There is a possibility that when you wish to talk to someone, it is not necessary that he or she may free to talk to you. Maybe he or she busy. And the fifth one and the last condition is inform the calling subscriber if the called party line is unobtainable for some reasons. So the first one is dial tone. So dial tone has 3 frequencies has been accepted internationally. The first one is 33 hertz or 50 hertz and 400 hertz. So in India, we are using 400 hertz, and it is a continuous signal which indicate that the exchange is ready to accept the dial digit from the subscriber. The number should be dialed only when the signal is heard. Otherwise, the digit dialed before the signal will not be considered. This will lead to the dialing of wrong number. Now the next is ringtone. After dialing the number of the called party, when the line of the called party is obtained, the exchange control equipment send out the ringing current to the telephone set of the called party, which is familiar double ring pattern. Simultaneously, the control equipment send out a ringing tone to the calling subscriber, which has a pattern similar to that of ringing current. The 2 ringing double ring pattern are separated by a time gap of 2 seconds, and 2 double ring pattern of a gap of 0.2 second as shown in figure. So first one frequency for 0.4 second, then a silent is there, then 0.4 second. The frequency may be 400 hertz or 133 hertz. In India, we are using 400 hertz, then 2 second gap,